Okay, so yeah, let's start. The internet is also playing up today in various way. Yeah, it keep saying it's okay, it's not okay, it's okay, it's not okay. So I don't know. Yeah, maybe a bit choppy today. Sorry about that. Yeah, I can see the stream is already very choppy. Uh, we'll see. We hope that it will get better. I just feel like a certain time that is not good because yeah, I don't know why. I still don't know why. We will sort it out. Yeah. Hmm. So lots of tasks today: generic types, traits, and lifetimes. So yeah, we would talk about lifetimes this time because remember yesterday we have a bug that really bugs me is that it said that the thing doesn't live long enough. So yeah, there's the problem um, of the lifetimes of things. So let's see. Functions can take parameters. Yes. Yes. So we have already used those generic with option, vec hash map, and result. This chapter you explore how to define your own types, functions, and methods with generics. How to extract a function to reduce code duplication is always a good idea. Use the same technique to make a generic function from two functions. Ooh, that differ only in the types of the parameters. Since types are generic, I think it makes sense to have some functions that are generic as well. So that makes sense. Then you will learn how to use traits to define behaviors in a generic way. Combine traits with generic types to contain a generic type that accepts only those types that have a particular behaviors. And supposed to just any type. So we have more control about what we accept and what we are not. Then we'll talk about lifetime, a variety of generic that give the compiler information about how references relate to each other. So yeah, it's about the reference, like how long do they live and things like that. Allows to give the compiler enough information about borrow values so that it can ensure reference will be valid in more situations than it could with our help. That would be helpful if we can extend the lifetime of the thing we had yesterday. That that we have something that doesn't live long enough and we have to copy it over so it stays on. Removing duplication by extracting a function. Yeah. I feel like chapter 10 is a long chapter and we can't go through it all today with the limited time and my limited bandwidth of my internet. So, yeah, let's go through a little bit of it. I don't aim to finish it today, but let's see how far we can get into it. Generic allow us to replace specific type with a placeholder that represent multiple types to remove code duplication. So look at how to remove duplication in a way that doesn't involve generic types by extracting a function that represents specific values with a placeholder that represent multiple values. Apply the same technique to extract a generic function by looking at how you recognize duplicate code. Okay. So we have a main rs here, and what is the duplication? So largest is the first one, and then we go through them, and then if it's bigger than the largest, then it's the new largest. This is quite standard. This is what I would do things most of the time, but I guess it's not the most yeah, so it's just finding the largest number of a list. Yeah, so this list will have 100. So we will make the smallest, I guess. No, what are you doing here? Okay. So we have two lists. We have to do it 2 times. So you can see there's the copy and paste. Of course, we can write a function to do this comparison. We can take a vector and then return a value or a reference of a value. So now what we do is to write the function largest, and then with largest we would take a vector of i32 by the reference, and then we would return the reference of the number. So we have that, we have the list, and then for each item in the list we compare, we do the same thing, but then we return the largest. So yeah, the largest is the reference, so we would return the reference. Yeah, because this item also the reference, right? So it's fine. So now we can combine these two functions, and then every time we just pass in a different number in the list to do that. So we have done this exercise. We see this is duplicate. We combine them into a function, and that's it. So that is, I think, is common in all these different type of programming languages. I'm very frozen on the stream. Sorry, very frozen. Ooh, yes. It's a slice. It's not a vector. Ooh, that's true, because we use the n, right? That become a slice. Then it's not a vector anymore. Yeah, n list is now a slice, not a vector. No, n list, yeah, n list, the list that we take in here. So let's see what the first part of this chapter talk about. Function definition. So we would have to have a function definition like all the functions. So we are talking about generic data type. So for example, we have two functions, the largest i32 or the largest character. So they are very similar. It's just that they take in different types. For example, they take in a different slice of a vector and return a different reference of a different type. So how can we combine these two? So let's look at it and see. So this is how you do it. I guess character largest is just like look at the bytes of it and then see how it compares. I guess like Z is better than Z is bigger than A. I think that's what it is. But I think that's how it is. So Rust naming convention is uppercase case for the type. To parameterize the type in a new single function, to name the type parameter. Yeah, so it's the T. So T is also follow the upper camel case because it's just one letter, and then that's the capital letter. And this also the default choice of a type. So now we use the type here, like option, result, and a lot of different things. Let's do it like that. And then we take the type and then return the type. So this is making the type become a parameter. Then we can combine these two because these two only differ by the type. Yeah, so this is how we do it. We can then combine them, and then when we use them, it's the same name, but I guess it's depending on the type that you pass in. Oh, actually you have an error, so you can't do that. So what you can do is so what's the problem? Oh, the problem is that this bigger thing is wrong because we don't have a bigger than operation for this generic type. So because this bigger than operator, it is in character, it is in i32, but it's not in this type that you just declare. So it doesn't work. Yeah, so you have this error, but otherwise it is very easy to use. It depends on what you put in, then it will work as well. So yeah, the parse. So how can we fix that? Help type mention. Oh, so you have to use parse ord, which is a trait, and we haven't learned it yet, so we probably want to learn that. compare values of type T in the body, we can only use type which value can be ordered. The standard library has the partial OR thread that you can implement on types. Yeah. So that's the problem. We haven't implemented the partial OR for this T type. So it doesn't work. So we've got to fix it later when we learned about it. So in struct, you can also use this generic definition for it. So for struct, it's similar. You have this little t here, and then x and y can be this type. So t can be any type. It could be a number, it can be a float. So this will work. This will both work, and it will help us in our median before. That will check both types instead of creating another enum, which is a bit tricky. So yeah, I guess like the more we learn, we can go back and see all this silly exercise that I've done, the silly code I've written, and then fix them. But yeah, we'll see. Maybe when we finish the book. So we have point. So point can take any type. So it could be. But this will have a problem because point need to have the same type, right? So T. So in this case, I guess you have to create an enum with both integer and float, and you can just say like, okay, yeah, point will take that enum type, so they can be anything. But yeah, you can't do it like that. You have a problem. You will say that, oh, because this is integer, this need to be integer. They need to be at the same type. So yeah, so or you can have two types for the two things here. You can have T and U, so they can be different. So or they can be the same, or you can do it like that, and it could also work. So we have seen it before, that sum will carry the T, which is can be anything. It also works. So just like this example, we can also have an error type associated with error. That's also fine. Yeah, we have seen that before. We're just reminding ourselves. And method definitions. We can also use this. We have to use the T here as well. I think because this is very interesting because the struct have this, but this is using T here. Can I change this though? Can I change it to something else? What does this T associated with? So function, I would take a self. Take the set of all possible types. Yes, which includes types that can't be ordered. Yeah. Yeah, I guess this will be super complicated, but I'm sure they will come back to it later when we learn about it. Whoa, I got a lot of messages. I don't know if you can hear it. I got a lot of Discord messages. Sorry about that. People are trying to get to me. So for this one, I have a associated function, and I would have or method, or we can call it method because it's take a self. So so the self, and then we returned a type T. So T can be any type. It depends on what you put in during the compilation. And then so this is the name of the function. It returned. Oh no, this is I'm slippy again. So X is here is this, so it's a getter basically. This is what it is. But I still don't know why there's a T in the input. So I want to know what's going on. So we have a point, then we can have a getter of X. Then we will have X. Yeah. So just after import, so we can use T to specify that we are implementing methods. On the type on T. Yeah, we have to declare because it's for type T or type point T. The technique T is a generic type after input. Rust can identify that the type in the point is the generic type rather than a concrete type. So point T is a struct now, but to tell Rust that this is also a generic type, we have to also use this, because this is basically the same as this, and we have to say again that the generic type is the T here. Yeah, I want to see the consequences of not doing that. For example, like this, what's going on with this? Okay. So we could choose a different name for this generic parameter than the generic parameter declared in the struct definition, but using the same name is convention. No. Methods written within impl that declares the generic type will be defined on any instance of that type, no matter what concrete type end up substituting for that generic type. We can also specify constraints on generic type when defining methods on the type. We could, for example, implement methods only for point f32 instance rather than on point T instance. So this will only work for f32, then we don't have to put the T here, because we replace T with f32, and this is not generic, this is static. It is only for one thing, right? We can't just put it's only for f32. So that's the difference. Yeah, so let me pause for a second. I want to set myself as away in Discord so it doesn't have the notification. So just 1 second. Okay, we're back. We should not have more sound anymore. Yeah. I would reply to people afterward. Don't worry, I will reply to people. I am a nice person. For input blocks, you basically have to declare all the generic you want to use. So yeah, if we don't declare it here, then it won't be registered as the generic. Then yeah, and because here we're not using any generic, we fix it on the what f32, then we don't have to put anything here. We don't have to declare any type after info. So that's the rule. That's the rule. Distance from origin method at an instance. So other than f32, then we don't have this distance from origin method. Okay. Generic type parameter is a struct definition and always the same. As you use, yeah, so those you use in the same struct method signature. Now it's getting complicated. So now we have x1 and x2 here. And for the points struct and x2, xy for the mixed up method. So here we have x2, xy. Signature to make the example clear. The method to create a new point is with the x value from the self point and y value from the passing point type 2. So we have an other will have two other values. They would be type x2 and xy, and then but we will return a point x1 and y x1 and y2. So the struct kind of defined. So by the time we get here, the struct we already probably already know the type of x1 and xy, right? but mixup will take in another point. So it depends on the parameter. Then we have to add the type, and then we would use our own x and then the others y. So that's why it returned x1 and y2. But the impel will still take x1 and y1. I guess is following the point here, because this want to match, right? You want this method to match the generic type for this point, the type of the point that it got associated with. So yeah, so you can mix it up like that, which is crazy. I don't know how often you do this, but yeah, this you can also do that as well. Yeah, purpose of this example is to demonstrate a situation in which some generic parameters are declared with impel and some are declared with the method definition. Here the generic parameter x1 and y1 are declared after impel because they go with the struct definition. Yeah, these need to match because you want this impel to be associated with the same struct, right? So you want them to match, otherwise like it's crazy. But then the generic parameters are declared after impel because they go, yeah, they're good. And then the generic parameter x1, x2 and y2 are declared after the fin mixup because they are it depends on which of these, then it will create a different one. So you will have a bunch of x1 and y1 here. I guess you will have a bunch of different types. Like imagine you can't use generic type, you have to write them. Oh, you will be crazy. So there will be a lot of combination. Performance of code using generics. So whether there's a runtime course when using generic type parameters. The good news is that using generic types won't make your program run any slower than it would with concrete types. I think because it's, you know, if it's hard-coded in your code, if it's concrete, then the compiler will figure it out and then optimize it, I think. Rust accomplished this by performing monomorphization of the code. I love this word. Using generic at compile time. Monomorphization is the process of turning generic code into specific code by filling in the concrete types that are used within the compiled. So yeah, just like what I imagine. If it's already decided in your code, it's not going to change. Your compiler will probably fill in all the blanks, expand it, and then optimize it. So it's probably gonna be fine. In this process, the compiler does the opposite of the steps we used to create a generic function. So instead of we making the code shorter for us to read, the compiler actually will expand it by filling in all the gaps, what kind of type you need, and then expand it. Because, well, we don't have to look at it after compile, and the compiler will optimize it, and it just need to run fast on runtime. Look at places where generic code is called and generic code for the concrete type, and the generic code is called with. Look at how this works. When Rust compiled this code, it performed monomorphization. During this process, the compiler reads the values that have been used in option T instance and identify two kinds. There's like a I32 and the other is F64. So two options are used. So I32 or F64 here. So as such, it expands the generic definition of option T into two definitions specified to I32 and F64, thereby replacing the generic definition. So monomorphized version of the code looks similar to the following. So this is, yeah, so of course this is just for our illustration. It's not actually looking like this from the compiler, but it will expand it into two enums. One is I32 and one is F64, and then you are using this one and that one. The generic option T is replaced with the specific definition because Rust compiles generic code in the code that specifies the type. So no runtime course yeah, it will have just the same as if we write it out like that. The process of monomorphization makes Rust generic extremely efficient at runtime. So because it got monomorphized at the compilation process, so it's very fast at runtime. I don't know whether like maybe the compile time will take longer because we have to monomorphize it, but we don't care too much about compilation time. Maybe it will affect our development time, but we just want the program to be efficient, then it doesn't cost us anything at runtime, which is good. Next, traits. I think we can still go through this, right? How long is this? Whoa. Okay, I think half an hour we can maybe read through this and then not do any exercise, because I know I would spend 10 hours just doing one set exercise. Oh, monomorphization. Okay, someone need to read it to me. I don't know. My brain is very dumb. yeah. It's a very funny word. I love it. A trait defines functionality a particular type has and can share with other types. We can use traits to define shared behavior in abstract ways. We can use trait bounds to specify a generic type that can be any type that has certain behaviors. So, interface in other language. Ooh, okay. Let's look into it. A type behavior consists of the methods we can call on that type. Different types share the same behavior if we can call the same methods on all of those types. Traits, the definition, are a way to group method signature together to define a set of behavior necessary to accomplish some purpose. For example, let's say we have multiple struct that hold various kind and amount of text. A news article struct that holds a news story filled in a particular location, and tweet that can have at most 280 characters. We all know that. Along with metadata that indicate whether it was a new tweet, a retweet, or a reply to another tweet. I guess Twitter is not as popular as back then. We want to make a media aggregator library create named aggregator that can display summaries of data. So we need an aggregator. Can store a news article or a tweet. So it could be a very long news article or a very short tweet. To do that, we need a summary from each type, and we will request a summary by calling a summarize method on instance. Public summary trait that express this behavior. So first of all, it's public, and then it's trait, it's a new thing, and then summary, and then we have a function. So it's like a collection of functions. So we will have more than this, I guess. So summarize, and then self, and then string. So we declare a trait that using trait keyword that the trait's name, which is summary, we want it to be public, so it's fine. So we don't provide an implementation here yet. We just stop it with the semicolon. Right. So each trait can have multiple methods, so we're going to add more, I guess. Let's set one per line, and each line end in a semicolon. So we have defined this desired signature. For some summary trait method, we can implement it on the types in our media aggregator. So what does it look like? News article will have headline, all these things, and then a tweet will have username, content, reply, or retweet. So import summary for news article. So for news article, summarize will look like this. It will just format it by something like headline, by author, and location. For tweet, instead, we will have username and then colon and then content. So it's just that we are implementing summarize differently for different structs. for different types. So, and then in aggregator, are they all aggregator? Is it another file? It may be another file. So this is the library, and we have packaged this library as aggregator, and then this is how you can use it. So we use them, so we can just call in all these things, good things. So tweet equals to tweet, and then print line, and then tweet dot summarize, and then this will get formatted accordingly, according to the tweet summarize. Other crate that depends on aggregator crate can also bring the summary trait into scope to implement. So you can add more, implement summary on their own type. One restriction to note is that we can implement a trait on a type only if at least one of its trait or the type is local to our crate. At least one of the trait or the type is local. For example, we can implement the standard library trait like display on a custom type like tweet as part of our aggregator crate functionality, because tweet is local. So either one of them need to be a new thing that we are creating locally. So for example, in this case here, we have we use the display trait, but the type is our type, the tweet we we created locally. So then we can do that, or we can implement summary on vector in our aggregated trait crate, because summary is also our thing, right? We declare it, even though vector is a standard library thing, and we can do that. So you can't have two that is not created locally, then it doesn't work. For example, our display trait on vector, then you can't implement that in your aggregated crate because they are both in the standard library. It's not yours. You can't do that. Part of the property called coherent, the most specifically the orphan rule, the name because the parent type is not present. You can't just grab two things and combine them and call it a new thing. You need to be together with where it got created, at least one of them. Other people's code can't break your code, and vice versa. Without the rule, two crates could implement the same trait for the same type. Then Rust we don't know which one to use, so you can't overwrite things, and it just got very confusing. So yeah, you can't really like, oh, I will rewrite the display trait on vec_t because I want it to behave differently. You can't, because then there will be two implementations and Rust don't know which one to use. Then you just can't say, oh, because this one is local and then use that one. No, you can't. Default implementations. So sometimes it's useful to have default behavior for some or all of the methods in a trait instead of requiring implementation for every single one. Again, we want to save time. Then, as we implement the trait on a particular type, we can keep or override each method's default behavior. Then now you can override because you use something that is default, and then you can override it. But since it's local, then assuming that you know what you're doing, then it's fine. You're overwriting just your own code, so it's fine. The method. So instead of that, we can have definition here, but this will be the default. So it's read more. So just print out read more if it's so that's default. So article. So yeah, if we don't implement anything, we just like leave it empty, then it will probably call in the default. So yeah, so this will be the default because if we don't take any definition here, creating a default implementation doesn't require us to change anything about the implementation of summary on tweet, so it will still use whatever you did before. The reason is that the syntax for overriding a default implementation is the same. Syntax of implementing a tree method that doesn't have a default implementation. Yeah, so it's the same, but because it has a because it has its own implementation, it won't use the default. So we could define the summary trait to have a summarize author method. Implementation is required. Then define summarize method that has a default. So this is what we do here. So this one, there's no default. You have to implement it for everything. I think otherwise you get punished by the compiler. So okay, the method one can add averaging method. Ooh, extension trait. So yeah, so you can add more methods to other type as well. So yeah, here we have so we have this, and then to use this version of summary we only need to define summarize author when we implement the trait on a type. So for trait we do this. This the username is the author. After we define summarize author, we can call summarize on instance of the tweet struct, and the default implementation of summarize will call the definition of the summarize author that we have provided. Because this is summarize author, so it will just use that. So it will use the one that I've defined, but then it will use the default. But these two will work together, so it's fine. Without requiring us to write any more code. Yeah, so this will work because I called summarize. Summarize will call this one, which is the default, and then if summarize author, then I found this one here, so it's fine. Create some parameters. So okay, so now now I take in, so this function I take in the traits in notified, which is a function. Explore how to use traits to define function that accept many different types. Use summary trait that we have implemented on news article and tweet types. Define a notification function that call the summarize method on its item parameter. So which is some type that implements. So this means that any type that have a implementation of the summary parameter, then is fine. Sorry. Any type that have a impl of summary trait, then it's fine. So yeah, so this one I have written the summary for the tweet, so this is fine. Yeah, that's very handy because you know that summarize is in summary, and then if they have implemented it, then they will have it, so there's no error. Yep, this is very handy. This is like you don't have to check whether there's this like implementation. If not, like panic, whatever. Yeah. So this is good. The trip bounds syntax. Wow, we are now using it here. So note if I take in a type that has summary trait, and then also an item that is within that type. Also straightforward case, but it's actually syntactic sugar for a longer form known as the trait bound. Oh, okay. So this is actually syntactic sugar of this, which is saying like, oh, all the type that had a summary and then item is need to be in that type. This longer form is equivalent to example in previous session with small verbots. We place that trip bounds with the declaration of the generic type parameter after the colon and an angle bracket. The input trait syntax is convenient and make it more concise code. It's easier to see. While the fuller trait bound syntax can express more complexity in other cases, we have two parameters that impel summary. For example, we have two things, right? Then we have to do this twice. But if we have two things, if we put it here, then I guess it depends. Right. Specific multiple trait bounds with the plus symbol. So is it that we need summary and display to be available? So we can also write this, right, like this. Yeah, with both, so need to have both. Can we have or? I don't know. That would be very weird, I guess. Yeah, I guess if you want to have or, maybe you can again create another enum, maybe that is like that type that have summary or that type that have display, something like that. Ooh, okay. Yeah, or like that, or like that, right? Different combination, different ones, but like, you know, crazy. This is getting more and more crazy. Okay. Okay, you can use a where course like this, but so what it's trying to do is that, oh, T is supposed to be display and clone, U is like clone and debug, and then you write like that, which is a bit of a headache. So you can write it like this, T and U, but then you can use a where later that say like, oh, like T is this and U is that. So okay, less cluttered, yeah. Return type that implement trait. So also use the input trait syntax in return position like that. Using input summary for the return type, we specify that return summarizable function returns some types that implement the summary trait without naming the concrete types. For example, it returns a tweet, but the code calling this function doesn't need to know that. The ability to specify return type only by the trait it implements is especially useful in the context of closure and iterators, which we will cover in the future. Closure and iterator create types that only the compiler knows, or types that are very long to specify. So input trait syntax lets you concisely specify a function, return some type of implementation that iterates the trait without needing to write out all of the types. However, you can only use input trait if you return a single type. For example, this code that returns either a news article or tweet with the return type specified as impulse summary wouldn't work. Returning either a news article or a tweet doesn't allow due to restrictions around how input trait syntax is implemented in the compiler. So that's the more complicated reason, but then like input summary is kind of so if it only return one type that has the summary, but you don't know it yet, maybe like for example iterator, when it got generated then it got split out, then you know, then it's fine. But if you have an if and else, then you can't. So it's a bit of a pitfall here that you could easily make this mistake. Use trait bound to conditionally implement methods. We can implement methods conditionally for types that implement the specified trait. For example, the type pair T always implement the new functions to return a new instance of pair T. self is a type that aliases for the type of the impl block, which this case is pair T. But in the next impl block, pair T only implements the CMP display method if its inner type T implements the partial OR trait that enables. This is complicated. Let's see what's going on. So we have a struct, we have a pair. So we have a new function that will return itself, which is a pair. And then with x and y, but x and y is some type T. And then now I would have this com display, which will take itself, but the type needs to be but the type needs, but it's for itself, but itself needs to have the type T of itself needs to have the display and partial OR here, because then I can compare them, right? And also I can print this out. So yeah, because I need to compare them. So if they don't have it, then sorry, we can't check you. And I guess displays is for this print line here. Yeah, so otherwise this won't come out. So this is the condition that we can add without specifying which type we want to that is allowed. So as long as you fulfill that rule, then it's fine for you. Also, conditionally implement a trait for any types that implement other traits. Implementation of a trait on any type that satisfies the trait bounds are called blanket implementation, and are extensively used in Rust standard library. Tostring trait on any types that implement the display trait. So we'll implement this for T, but if T has display, then we'll implement it for them. So now I see more reason why this is like the T is written here because I only want to implement things that satisfy this condition. Right. Because the standard library has this blanket implementation, we can call toString method defined by toString trait on any types that have. So anything that has display, you know that there will be toString because they also have the toString trait. We can return integer into their corresponding string value because all the integer have display, so it's fine. I think this is really cool. It makes things very explicit. That when you have, I think it makes sense, right? If you can print it out like that in a string, then you probably have the toString method, so they match. Write code that use generic type parameters to reduce duplication. Also specify the compiler that we want this generic type to have particular behaviors. For example, you can set up all these rules, and yeah, and it will make sure that you provide a correct behavior in dynamic type language. We get an error at runtime. I've seen that a lot in Python. Call a method on a type that doesn't define the method. Wow, I remember that a lot of times. But Rust moved this error to compile time, so it won't be. Well, I guess Python doesn't have a compile time, so yeah, everything is a runtime error. Most of them, Python will still check whether you have like syntactic error, then it won't execute. But yeah, a lot of things are on the runtime error. We don't have to write code that checks for behavior and runtime because we already check at compile time. So if you have something that compile and ship, then probably it's good to go. Improve performance without having to give up flexibility of generics. That's really cool. So, like I said, it's almost an hour. Because I have a feeling that, so let's have a peek. At the end, we have some exercise, right? We'll spend forever to do that. No? Oh, it doesn't. Okay. Do I want to read it? Do I not want to read it? Do I not want to read it? But lifetimes is a bit of a headache. I'm a bit, still a bit scared. I want to end the stream now because I am really tired. Yeah, I would maybe save that for next time. Save this for next time. 10.3. and more things to come. So thank you so much for watching. And again, I will see you next time when I keep on reading the book. And we are actually doing good. We're almost halfway, right? So we are doing very, very good. But again, I'm sure that I won't read it only once. I'll read this book many, many times. But after reading it, we'll do some exercise. Then we would always come back to check if I forget things. So yeah, we will continue our journey tomorrow. So see ya.